Hello, everyone, and welcome to the second lecture where we're going to be covering the basics of programming a little bit more in depth. First, I would like to apologize. My audio today is going to be a bit lower quality than what it normally is. I'm currently working with a temporary setup. However, by the next lecture, I should be using my regular setup and the audio quality should significantly improve. Now, in this lecture, we are going to cover a lot of things. This is the agenda. I want you guys to have a quick picture of what's going to be covered. We're going to cover math operators, data types, variables, formatted outputs, and functions. These are all extremely important parts of programming that will really give you the tools to make really powerful programs. Now, this video will be most likely somewhat longer than the regular videos, and it is a bit more confusing because a lot of things going to be a lot of different concepts and topics going to be covered in a single video. So it is completely normal to finish this video and have doubts and questions. What I recommend everybody do is to rewatch this video multiple times and code along as the video plays. So if at any moment you want to try something, feel free to pause the video, try it yourself, change the code a little bit, just play with it. This video will be confusing and you are expected to not get it upon your first viewing. Please do as many viewings as needed. And if after 2 or 3 viewings you still have questions, please feel free to email them to us and we'll get back to you as soon as possible. All right, so first up, we're going to talk about a little bit about math operators. So every single programming language can perform, math operations. The complexity of the math that they can perform varies from programming language to programming language, but most programming languages can perform really complex math to do some really cool things. So to do these, complex math operations, you need something called, math operators. This is what tells you what to do. This tells you what operation is the one you're going to be performing. So if you have 5 plus 3, the operator there is the plus. That tells you have to take 5 and then add 3 to it, right? So math operators are an extremely important concept in computer science and math in general. So here's a list of the mathematical operators present in Python. This is just a small list of them. There are more, but these are the most important ones. So there's plus and minus, and they use the regular symbols, plus and minus. They add and subtract. And you have slash and asterisk, which do divide and multiply respectively. And these four symbols should be very familiar with you, for you guys. These symbols are the ones present in your calculator. They're present in the math examples you guys do. But then we're going to get into some stranger symbols like the percent symbol. Now, this symbol doesn't mean take the percentage of. This symbol is the modulus symbol, and it's used for calculating remainders. So you know how you have 3 divided by 2, your answer is going to be 1 with remainder 1. Well, if you want to get the remainder 1, you have to use the modulus symbol. You have to do, 3 modulus 2, and that would give you, return the remainder of 1. That's a very useful operator that you guys will be using for sure in future assignments and just in general in programming. The bottom 4 math operators are somewhat special. They're logical operators. They compare things instead of really operating on things. We're not going to be discussing these too much in this lecture. However, they will be the main topic of discussion for next lecture's video. All right, so here's a couple of examples of code that uses these mathematical operators. Here we have 3 lines of code. And I want you guys to think for a second, what do you guys expect these lines of code to do? So just reading through them, what we're looking at is we're looking at a print, statement, and within that print statement, we have the actual mathematical, expression. The top one says 2 plus 3, whatever that is, print it. The second one says 2 times 3, and whatever that is, you print it. And then the bottom one says 3 divided by 2, and then whatever that is printed. So what do you guys think is actually going to be printed? Like, what do you guys expect to be printed? All right, so I'll give you guys a brief second to think about it, and then I'll show you guys real quick. All right, so you guys should have thought about it. These aren't too hard of math problems to solve. So now let's see what we expect to happen. So if you run these lines of code in an interpreter such as idle or RIPL, this is what you end up getting. Now there's 2 plus 3, that's 5, and then there's 2 times 3, that's 6. But then there's 3 divided by 2, which is 1.5. Now, for us, these kinds of data are exactly the same. They're just numbers, right? This is no big deal. But for computers, there's two distinct types of data here. They are integers and then they are floating point numbers. Integers are just your regular run-of-the-mill number 1, 5, 38. And then floating point numbers are numbers that have decimals in them, like 3.3, 4, zero point 0.5, 3.14, those kinds of numbers. And computers handle these in fundamentally different ways. Um, so that is why computers have these things called data types, which we'll discuss in a second. But these lines of code print out, these results, which is what you expect. Computers, and us, while we do math in very different ways, the overall abstracted view of what, results tends to be the same. So Python has a lot of different data types, but these are the most simple, most fundamental data types. You will use more, but these are usually the ones you always come back to. These are the ones that you'll use the most and that really have the most impact in your code. There's integers, which are just whole numbers, like I said earlier, 1, 2, 3, those kinds of things. There's floating point numbers, which, are numbers with decimals in them, like 4.8, 90 point, 73, things like that. But then there's strings. We haven't really talked too much about strings, even though we've kind of used them already. Strings are just, they're kind of like sentences. They are data that contains character, that contains, letters. They can be as long as a single letter or as long as, several sentences. These are the fundamental data types. There are a lot more, and we will go in depth into each one of these and into many more as the year progresses. But right now, these are really the ones we have to worry about. So first, integers, they're the simplest data type. Like you cannot get more simple. They're just numbers. We've known numbers our whole lives. 1, 2, 3, 4, 5. Those are integers, and then you could do math on them. Of course, you can do. You can add, subtract, multiply, divide. You could add a bunch. You can do a bunch of different operations. You could also do get the remainder. You could also use exponents in here. But integers are the most fundamentally simple ones. Because if you do 7 plus 8, you can do that in your head, right? If you do, 48 minus 10, that's also very simple. And computers can do it much faster than us. You can give them, 300,000 multiplied by 473. I don't know what that is off the top of my head, but a computer could just do it instantly. And that is the most basic one. You will probably use integers the vast majority of the time whenever you're programming. Next up, there's floating point numbers, which, like I mentioned earlier, they're just numbers with decimals in them. Um, we usually call them floats for short. And then two examples of some floating point numbers are on the screen, 3.14 and then 1.618. Bonus points if you know what these numbers are and why they're important. And you may use them on assignment further on, hint, hint. But floating point numbers are really where it starts to get a bit more complex because whenever you're doing advanced complex mathematics, you will run into floating point numbers, and that's when it gets significantly harder for a human to work through those problems. But for computers, they're still the same problem. Nothing has changed mechanically, and they can just do them as quickly as they could with regular integers. Now, lastly, there's strings, and strings are a bit different than the other types of data. So strings aren't aren't strictly a data type; they're more of a data structure. But for all intents and purposes, for now, they can be thought of as a data type. But we're worried about the distinction between these two concepts a bit later on. And they're usually used to store, characters in a sequence. A string of characters, if you like. That's where the name comes from. Now, we have been using strings recently. Whenever we do print statements, whenever we want to, do print out a statement into a console. And in Python, the way you write strings is by writing whatever you want, but putting it within single or double quotes, as shown on the screen. Now I've been talking a lot about all these operators and data types, but I haven't doing a lot of coding. So I want to take a quick break from the slides and show you guys a little bit of actual coding. Now here I have idle set up. On the left, I have the actual Python shell, and on the right, I have a blank program. I want to show you guys real quick that the shell is actually a very powerful tool. You can run single commands in the shell, just like you would run a list of commands in the actual program. So for example, if I do 4 plus 9, that'll return 13, just the same as I would have if I were to, run it over here, save it, and then if we run it, now nothing's going to come out. That's what we expect. See, that ran, but we didn't do anything with it. But if we print it, then and then we run it again, then we expect to see it. See, we see the number there. Now, the reason why if I run a command in here, 13 times 21, it gets displayed on the shell is because whatever the statement returns will be given to the shell to print out automatically. So that would be the same as me doing something like this, if I were to do that and I were to run it. Now, that's not possible here because return statements, as we will discuss further into this presentation, only function inside functions. But mechanically, that is what's happening whenever you run one here. Now, if you want to test, if you, for some reason, you want to use Python as your personal calculator, you can, of course, do that. We can do 21 minus 10 times 2, right? And that'll work just fine. And if you notice, the standard order of operations is still followed here, right? It did 10 times 2 first, which is 20, and then it did 12 minus 20 to get that -8. The order of operations is a universal thing in all mathematics, PEMDAS, right? That will always be held in programming as well, unless you bypass it through the use of PEMDAS, right? Now, we'll discuss that a bit later, the nuances of the order of operations, but for now, just remember that it functions the exact same way as it does in regular math. Now, if I were to go over here and just write a quick program that, let's just say, does this. Let's do print hello. Now we know that this data type is a string, and we're actually printing out a string. If we run the function, it'll print out hello. But I could also do that over here. I could do print hello, and then, I could run it, and, oh, let me close that. I could run it, and it also prints it out. And then I could go and do all of the other operations. I could do, 5 modulus 6, and, oh, let me print it out, actually. Print 5 modulus 6, 7. All right, 6. And then we run it. Oh, yes, we save, of course. Then we run it. And that makes sense. If you divide 5, by 6, you get a quotient of 0 and a remainder of 5. And if we do 7, modulus 6, again, remember, the modulus symbol is just the remainder symbol. It's just like the remainder. 7 divided by 6, that's 1 with the remainder of 1. But what if we do 9 divided by 6? What do we expect there? So 9 divided by 6, you expect a 1 with remainder 3. To get the quotient part, you just do the divide symbol. And to get the remainder part, you do the quotient symbol, and that's how you get everything. So that's just wanted to give you guys a quick exposure into what it actually looks like in code when you use these math operators and these data types. Before I forget, let me do some quick float math. So if we do this, we get 6.3. This is just to show you guys that all of these expected data types, that all these data types work with the expected math operators the way you expect them to. So see, if I divide that by 2, I get roughly half of it, right? And just wanted to give you guys a quick exposure to this. We'll go back to the slides in just a second. So we've been talking a lot about data and data types, but we haven't really talking about how we would use these types of data in a real program. So far, we've just been writing numbers, but what if you want to write a program that we don't know what the number given is going to be, where we have to, add some dynamic code that will be able to handle any number? But if we need to be able to store, values, that's where variables come in. Variables are just, they're a tool that we use to store information. Now, you can think of variables as containers that hold, certain values. You can think of them as like a little box, right? And you put whatever you want in that box, you give it a name, and then you can refer to that box later on whenever you want. You could also open up the box later on, take out what's in it, and put something else in it to change what's in the box. So these are what variables are. They're very similar to variables in, algebra and mathematics, where they're just a placeholder for something else. Now, in Python, variables can be just created just by writing the name. You just write whatever you want the variable name to be, and you set it equal to whatever you want. So these are a couple of lines that show you examples of variables being created. That first line right there, it shows you an int being created called myInt, and then giving it the value of 4. So later on, whenever you write myInt, that's going to represent 4, and you can update that value with whatever you want later on. So all these variables are of different data types. That first one's an int, the second one's a float, and the last one is a string. And this is how you would, store values and save them for later use. Those last two lines are very interesting because those last two lines are showing that you can store calculations and expressions in variables. Specifically that last line. That last line has no explicit numbers. It just the Python language looks into these containers, sees what's in them, grabs those values, and then does the expression. So, in this case, my int is equal to 4, my float is equal to 3.14. You subtract those from each other, and you end up at like, zero point 0.7, 0.76, 0.86, somewhere along those lines. And then that gets stored into my expression. And just by looking at what kind of data you're giving each of these, variables, you can tell what data type the integer is. That my int is an int because you're giving it an int. That my float is float because you're giving it a float, and so on. Now, something that's very, very important in programming is what you name your variables. Now, you should name them something useful that is not too long, not too convoluted. Now, sometimes it is good to name them something short, just off the cuff, X, I. There is a time and place for that, but most of the time you should be naming your variable something useful. For example, if you are doing an area of a circle calculation, you have to keep track of the radius. So the variable for radius could be r because that is, universally known to mean radius, or you could just name it radius and that would be equally as good. Bad variable names is when you use letters when there is no meaning behind them and you can't decipher what that variable means just by looking at the name. For example, look down there. We have E equals X minus F. I have no idea what any of these letters mean or what they could mean. I have no context. I have learned nothing from knowing these variable names. Whereas on the right, we have good names. I can tell, all right, my int, that's an int, and it's, I'm using it for something. My expression, that holds the result from an expression that I use. Variable names should be easy to read and understand what they mean at a first glance. But like I said, there are moments when you want to use X, you want to use I, J, variables like that. So it's a bit of a judgment call when you use short variable names versus longer variable names. All right, so taking a quick break from the slides again, I wanted to show you guys how you can use variables in your program, in a live way, right? So real quick I want to show you guys, you can use variables in the shell. Like we could still do, my var equals 3.114, and that is stored in the shell. If I were to do print my var, it's still stored in there. So you can still definitely do, math using variables within the shell, although it is much more complicated than just writing the regular program. Now here on the right, I have a program already written that really showcases that utility of variables. Here you can see that we are asking the user for two numbers, then we add them together, and then we print out what their sum is. Now, if you look closely, you will notice something a bit strange. I'm doing the input function that we used, last lecture to get information, but I'm putting that all within a call to this inf function here. Well, what I'm doing here is I'm converting whatever input I get into an int, because when you do the input function, you always get a string back, and I don't want a string, I want an int. And you can convert between data types via this method. I'm converting from a string to an int. Now, if I were to run this program, let me save it. Yes, it'll ask you for the first numbers. Let me say 101. And then it'll ask you for the second number. Let me say 99. And then it'll give me the addition of them. Now, if I run this program again, and I say first number is 1, second number is 2, I get 3. So the program has not changed, but every time I run it, I'm getting something different based on the inputs. This is where code can become very powerful. I didn't have to hard code the possibilities here. I just created a dynamic script that can handle any input given and provides the proper output. So, if I run it again, this will even handle negative numbers. If I do -3 and I give it 3, I get 0. That's what we expect. This just shows you really how powerful variables can make your program. They are the single most powerful and useful tool in programming. Um, and I just wanted to take a quick break from the slide to show you this. All right, so very important part of writing code is, documentation. Sometimes when you're writing the code can become very complex, and you might have to write something down to remind yourself or to explain to someone else what the code's actually doing. So a way to do this is through comments. So almost all programming languages implement comments. Certainly every single one of the mainstream and common ones to use implement comments, and they are a very useful way to explain what's happening in your program within the actual code itself, to your future self, when you're referring back to this program in the future, or to other other programmers that might be working on your program as well. So in Python, when you write comments, the way you do it is you just write, the pound symbol, the hashtag symbol before the comment. Um, Stuff that is commented is ignored by the interpreter. It's like it's not even there when the program is ran. That is just for us, not for the computer, so the computer just completely ignores it. Down there on the bottom is an example of what a comment looks like. It says, the following code calculates the result. If that line was not a comment, the program would not run, it would not work at all. But the fact that it has a little hashtag, a little pound symbol at the start, tells the interpreter, hey, ignore the rest of this line. It is not for you, it's for me. It's for us humans to understand the code. And the following line does what the above comment is describing. Um, Now, there is a bit of comment etiquette, depending on whose class you're taking or who you're working for or what you're doing is how you're going to comment. Some places have very strict comment rules that you must follow. Some professors have very strict comment guidelines that you have to follow or you get points taken off. During this course, just practice good commenting etiquette for you that makes sense for everybody else, and you'll be fine. So when you comment, you have to make sure you're giving information that's useful. Don't give information that's obvious, from looking at the code. Um, if the way a certain portion of the program works is not immediately obvious, then it needs a comment. The comment should always tell you why, not how. Unless the one exception to this is if the how is very complicated, if it doesn't really make sense, if you can't really understand it at first glance, then feel free to comment it. But these are two examples of bad and good comments. So that first example, they're saying the comment says assigning the starting value a value of 56, and then the next line does that. But the thing is, the next line, just reading it, it tells you that that is what's happening. Now, the second example is an example of good commenting. It says defining a sales tax of 10%, and then it does it. If I'm seeing this, I might not know that 1.1 would signify a total that includes a sales tax of 10%. So That second one is a good example because it tells you why you're doing that. It tells you why it's relevant. It's not just saying how when the how is plainly obvious. Um, so here's a couple more examples because this is very important. So the above example is very good because it tells you what's happening, not the how, but what's happening. So that top line is calculating the area of a circle. The area of a circle is just pi times the radius squared. Now, really quick side note, in Python, you could do powers very easily by just doing asterisk asterisk. So if we do radius asterisk asterisk 2, that's the same as radius squared, or radius to the second power. That's an example of some of those extra operators that you're going to be seeing later on during the course, and while you do your own research, which we always encourage. Then on the right, it says calculates the area of a circle. Now, if you don't know that this formula is the area of a circle, that comment would be very useful to understand what's happening. But then on the bottom, we have what are probably among the worst comments. See, the bottom line of code, all it takes results, then it does, 3 times 2 minus 3 plus 4, and then it stores it in a result. And then the comment just says that exact same thing. It says this line takes a number, multiplies it, then removes and adds. Well, I know that just by reading the line. I learned nothing here. This just took up 2 extra lines of code for no reason. So no comment would have been better than this comment in that second example. However, that is usually a pretty rare case. If your comment adds something, it's probably better to keep it in than to remove it. It's easier to trim down, excessive comments later on than it is to create comments from scratch that weren't there in the first place. All right, so back to the slides. Now we have to talk a little bit about output formatting. Now, so far we've just been printing out unformatted output. What you print out is exactly what you get. But the problem is that that is very limiting. Python provides a bunch of formatting options to make print statements a lot better, a lot smarter than what we're currently doing. So far, we've been doing print statements like the one shown on the screen right now. We just print out a string, then we print out what we want, and it's separated into 2 lines, and that's not very pretty in my opinion. Now, Python gives us the tools to change this into a much more efficient and appealing way. So the way you would do that is by using output formatting. Now there's a bunch of different ways you could format output, and a bunch of these are discussed in the official Python documentation. While you are coding, always, always, always refer to the Python documentation with any questions, any concerns or doubts you may have. This is your best friend along with Google, in my opinion. A programmer's best tool is being able to find out the answer, not knowing the answer. And being able to find out the answers, being able to Google efficiently, knowing which websites are good, which websites are bad, and which pieces of information are contained where. So this is an example of that. Information regarding output formatting, that would be discussed in the Python documentation. Um, Whereas if you're running into a very specific issue, that might be something that's found on Stack Overflow instead. Now we're going to discuss a couple of these, but I highly recommend everybody to go through that link and see all the different kinds of ways you can format your output. Now, the easiest way to format output is just by using something called percent codes. This example here uses that. You use a percent code, and that kind of creates a placeholder in the string that you will fill in later on. So that line of code there prints out the output that's on the bottom, and as you can see, the percent %d was replaced by the value next to it by the 3 plus 4, which is 7. Now, the way this works again is through the use of percent codes, and to format output, you need these. One of the methods is to use these percent codes. So there's a bunch of different percent codes, but the ones we're more concerned about right now are the ones for integer, floats, and strings. Now for ints, it is percent %d. For floats, it is percent %f, and for strings, it is percent %s. And the way it works, you just put that percent code in your string wherever you want to put a variable or a data type in. So For example, right there on the bottom, that huge print statement contains one of each of these percent codes. So it says my name is some string. I have some int batteries that each cost some float. And then after that, I end the string, I put another percent symbol, and then within parentheses, I write down a list of all the data I want to fill in order. So the first data in the paren will correspond to the first percent code. The second piece of data will correspond to the second one, and so on. If I were to run this line, I would get the output that's on the bottom of the screen. My name is Jan. I have 4 batteries that each cost $3.99 each. And that's generally how this works. And you can get very powerful with this. You can create highly dynamic code that greets the user via their name every time you run the program, every time you enter a certain function. These percent codes can give your code very, very powerful input and output options. Now, you might have noticed a small issue earlier. If I go back a slide, I wrote 399, but the output said 399,0000. What if I don't want that? What if I want it to cut off after 2 decimal points? Well, that's another output formatting tool. So there's this thing called, the width or the decimal or the position of the output. Now, this is a problem in when dealing with floating points because sometimes computers make mistakes. Sometimes they round incorrectly. For example, if we look at the earlier slide, specifically this example where we did my int minus my float 4 minus 3.14, to us we could do it quickly and get 0.86. But a computer might make a mistake when converting ints to floats and end up with something very close, but not close enough for them. So they'll just print out what they got. So in this case, if we were to print out my expression, we would have gotten 0.8599999 repeating. But that's pretty close to 0.86. And the way you fix that is by, doing this, by putting zero point 0.2 in front within the percent code between the percent and the F, you're specifying how many decimals you want. So in this case, if we said percent 0.3, we would get 3 decimals. If we said percent 0.1, we get 1 decimal. Right now we're doing 2 decimals, so we do percent 0.2F, and that gives us 0.86, which is what we expect. And this will allow you to ensure that only a certain number of decimals are printed out. If you go back a slide, in this case, it would have been smart to do percent 0.2F to ensure that since this is a monetary value, only 2 decimals are printed out. And so this is a very powerful tool that you will use when formatting output and ensuring that certain functions use a specific format, a specific decimal length. So there is another way that you can format your output. That's by using the str function. But the str function it works very similarly to the int function we saw earlier, where we converted a string to an int. Well, the str function, which stands for string, converts anything you give it into a string. So if you look here, I have 2 lines of code. The top one will not work because a print statement can only print out a single type of data. It can either print out a string or an int or a float and so on. It cannot print out a mix of the two. Really, that's not exactly what's happening. What's happening is that we're trying to combine more than one data type together. That's what those pluses are doing in there. But for now, you can just think of it as the print statement can't, print out multiple kinds of data at once. So we have to make sure that all the data within that print statement is the same type. And the way you would do that is just enclosing all the data within an str call. So the main issue in the top line is that 4. That 4 is an int, whereas those other 2 data types are strings. The two data types in this case would be, the avatar is master of all. That's a string on the left, and then there's a string on the right, which is, just elements. So we have string, int, string, and we're trying to put them all together, and you can't do that. We have to convert that middle data type from an int to a string. And the way we do that is just by calling the str function on that, int. And then you just have a total of 3 strings in a row, and then you can actually output that information. So you can use the str to convert numerical non-string data types to strings, and then you can use int or float to convert from any other data type um, to int or float, or whichever one you want. Okay, so now we're going to go into probably the hardest part of this lecture. We're going to talk a little bit about functions. So functions, they're an extremely useful part of programming and computer science. Like they are one of the most important tools. They are the screwdriver or the hammer of the programming toolbox. They let programmer reuse segments of code dynamically and easily. They can be thought of as a list of instructions that you can refer back to at any moment without actually having to rewrite these instructions over and over again. Now, this is an example of what a function looks like. This function, all it does is that it prints out 2 lines of code. It prints out hello world, and it prints out I was printed from a function. Now, by writing this function once, we can call it as many times as we want to without having to rewrite everything. So in this segment of code, I'm defining the function, what it does, what it's called, and all that good stuff. And then I'm calling the function 3 times right afterwards, and it generates, and the generated output is shown below. Now, this is the basics of this is a very basic function, but I wanted you guys to have a quick look of what it looks like when you do write a function, when you do use it, so you can easily see, that using functions saves lines of code, saves times, because in this case, had we not used a function, we would have to written a total of 6 print statements, one right after the other. But by writing this function once, we only need 3 lines of code later on to actually call this function and print out these lines of code, these lines of output. So yeah, it saves on time and code size, because sometimes you have to worry about how long your code is, because maybe the computer or the device you're going to be running your code on might not be large enough or might not have enough memory to hold a very long program, a very large amount of code. So those are things that you might have to worry about. Now, before we get too in depth into functions, I know that this is a very difficult topic, and it is normal if you do not get it upon your first viewing. In fact, it is expected that it doesn't really make sense upon your first viewing. Um, this is completely normal and expected. We want you guys to rewatch this video, a few times, code along, run these examples yourself, and then play with these examples, change them up a little bit, write your own functions, write your own little programs, and have fun with it. Because that really is the best way to learn this material, by writing your own functions, because that's when it's really going to click. I just wanted to take a quick moment to remind you guys that it might seem overwhelming at first, and it is overwhelming, but you will get past this by rewatching the video a couple times and coding yourself and asking us questions if after watching the video a couple times, it doesn't really stick. You're not really getting it. That's completely normal and expected. All right, so now let's take a look at the anatomy of a function and what all the parts in a function actually look like. So over here, I've abstracted out all the parts of a function, and so that we can go to them together. So first up, we have the def keyword. The def keyword is necessary to define a function. You need that keyword there. That's the first thing you write when you want to write a function. Following that, we have the function name. That's what the function is going to be called, and it's what you're going to write whenever you want to call the function, whenever you want to execute it. After that, within parentheses, you have a list of the parameters. Parameters are just a list of variables or data that you give the function in order to do whatever it needs to do. This is optional. You can have an empty parameter list if the function doesn't require any information, or you could give them, 5, 6, 7 different pieces of data for the function to actually do whatever it needs to do. Following that, you must have a colon. You must have that when you to finish the actual function signature definition part. Following that, you start on the next line and you indent once. This is critical. You must indent once in order to define the actual body of the function. All other lines within the function must be with one level of indentation at least. So we have the function body. That's where we actually do what we want to do our print statements, do our calculations, and it's all with one extra indentation line added. Now, at the end of the function, you can have a return statement. This is not necessary, but it's optional, really. It depends on what the function is doing and if it makes sense to include one. A return statement, what it does is that it returns specific value. So if a function is called, and it has a return statement, when the function finishes executing, it gives back a value to whoever called the function itself. Now, there's two types of functions. First, there's functions that can give back. Functions that can give back are functions that have a return statement that provides something to whoever called them. So this is an example. This function, all it does, it gets the name from someone and then it returns that name to whoever called it. So it needs a return statement at the end. And then at the bottom there is an example of how you would use this function. Maybe you're printing out my name is, and then you call the get name function to figure out what their name is. And then when that function returns, it returns the name that was provided to it to this line of code. So what ends up printing out is my name is, and then whatever name they provided. That's one type of function. Another type of function is a function that can take, a function that can be given something for further processing. So whenever a function is given a list of parameters, such as on the screen right now, we have def, we're defining a function called sum of two numbers, and then we're giving it num1 and num2. Whenever that function is called, you're going to give it those two variables, those two data types. Those two pieces of data. And then the function is going to do something, and then it may return something, it may not, but we are giving it something that it is going to use to process. This is how you get extremely useful and dynamic code. You're abstracting everything out in a way that your code will work with whatever you give it. This is an example of the code actually, of that function actually being used. So, we're printing out a statement with formatted output, which is pretty cool. And then within the actual line, we're calling sum two nums with 42 and 28. What's going to end up happening is that wherever you see num1, that's going to get replaced with 42, and wherever you see num2, that's going to be replaced with 28. And then when that function finishes executing, it's going to return result. And what that really means is that entire call, let me switch to this real quick. This entire call is going to be replaced by whatever it's returned. So let's say we have called this function with 42 and 28. The way it is there. What it's going to end up happening is that after it executes, this is going to turn into just 70. So what we end up doing is we're giving it 42, 28, and 70, which is pretty cool. Now, on the bottom, there's generated output, which is what we expect it to happen. And in the code, in the output, you can't tell what happened in the background, but by analyzing the code, you can easily tell that the function was called with those two specific parameters, and it returned that 70, which was used to print out. So being able to provide information to functions and being able to create functions that provide information back is really an important part of programming and is able to, create really powerful programs. So a very important part of functions is that order matters significantly. It matters in a lot of different places. It matters in the parameters you use, so it must match the order of the parameter list with the order that you are giving the parameters, but most importantly, the order in which a function is defined and when it is called matters greatly. A function will only work if it is defined before it is called. So for example, that first set of code shows us calling the function before it is actually written. That will lead to an error because sum2nums doesn't exist yet. But that second segment of code will work because sum2nums already exist and has been defined by the time the print statement runs and the sum2nums function executes. All right, so programming can be very daunting. There's a couple of points that I want you guys to really know. It's completely normal to be very confused and have a bunch of questions at this point. What I really recommend is to rewatch this video, several times. Let it really sink in, really play around with it. We don't expect you to understand this material with some master level understanding upon your first viewing. You should rewatch this. You should code along. You should stop the video, play around with the examples, make your own examples, and you know, just have fun with it because the best way to learn programming is to program. You only learn so much by reading and watching videos and seeing other people's code. When you really learn when it really clicks is when you're writing your own stuff, when you're doing stuff you want to make, when you create things that are useful to you. Now, after a couple of viewings, if it's still not making any sense, please send us some emails with questions to the email on the bottom of the screen. It'll really help us understand where your doubts and questions are because then we will be able to address them in future videos or just reply to you back with any answers that we may have at the time.